think it's very, maybe around 1,000 students also in geodesy and geometric engineering, around 500 students. Also in this event, also I share to my colleagues in the geospatial industry in Indonesia, also in government. I think this webinar is very interesting.
Yes, thank you for having us.
Yes, yes.
Yes, Bentley, of course, is a very long-standing company.
Yeah.
30 over years of experience and delivering solutions to advanced infrastructure with solutions for architecture, engineering, design, and in this particular webinar, we're going to present context capture for the reality modeling, which actually serves to be an input for basic input for many digital twins and digital cities moving forward. Yeah.
Okay.
Okay. How about we start? Shall we start this webinar?
Yeah. Okay. We start.
Yeah, I think so. Yeah, you can start.
Yeah.
Vika.
Okay. So I can start sharing my screen.
Anggita, Firman, please for admit our participants. First, I will show you a video, ITNS video, company profile of ITNS.
Okay.
The Institut Teknologi Nasional Bandung, widely known as ITENAS, is a private higher education institution concentrating on the academic majors of technology, engineering, and design. ITENAS was established on December 14, 1972, and was previously known as Academie Teknologi Nasional. By 1984, due to the growth in number of courses and majors offered, we became officially recognized as an institute. A little bit to the east in Bandung, which was once renowned as the Paris of Java, we stand as a single campus, which is the center of a healthy student lifestyle. Our institution was born from honorable purposes and objectives from the founders of the Yayasan Pendidikan Dayang Sumbi, who believed that every one of us should be able to reach higher education and live a better life. The foundation still keeps its promise to provide high quality and affordable higher education for everyone.
ITENAS sangat menyadari bahwa era globalisasi dan juga revolusi industri bukan hanya sekedar tantangan tetapi juga ancaman yang dapat mengikis jiwa nasionalisme dan juga karakter bangsa. Oleh karena itu, ITENAS menerapkan sistem kredit kemahasiswaan sehingga diharapkan dengan bekal soft skill, lulusan yang akan dihasilkan oleh ITENAS dapat cepat beradaptasi dan juga dapat produktif di lingkungan kerja nanti.
Our institution has 3 main faculties, which deliver 14 bachelor's programs and 3 master's degree programs. All the majors are of various academic disciplines and are primarily centered on engineering, technology, and design studies. In acknowledging the work of our capable students, passionate lecturers, amazing researchers, and attentive staff, we have achieved so much in the past 5 years. Along the journey of education inside our campus, we aim to educate each and every student to be a highly competent professional ready for the workplace. However, as educators, we are aware that the learning process does not end with simply refining professional skills. We also work with our students to grow more proficient intellectually, emotionally, and spiritually. The independent spirit and curiosity for learning of our students and alumni is well known, and therefore they are certainly capable of contributing to society. We are an integrated learning space which allows every student to be their best, a culturally knowledgeable, passionate human being ready to take on life's challenges. We provide every chance to prove our students' passion in science competition, research, seminars, exhibitions, sports, arts, and every performance to truly express whatever character each and every one of them has. This environment of supportive and continual assistance has been proven to encourage our students in their accomplishment at prestigious national and international championships. As independent as we are, our doors are always open for everyone who is interested in creating a better education to contribute more to society and grow together. We have a record in collaborating with many universities, government and private offices, companies and worldwide industries through our alumni, friends and relatives around Indonesia and around the world. Today, our alumni numbers over 20,000 people. Our proud alumnus is ready to contribute across the nation and all over the world. The more graduates we have means a greater determination we need to accommodate in order to maintain our qualities. We understand that technology, science, design and engineering always need the finest in every field of work. Welcome to Institut Teknologi Nasional Bandung. We hope for a better mutual connection with you. Together, with your support, trust and cooperation, we can be an excellent and independent higher institution with the aspiration to build better human resources for the nation and the world.
Baiklah, Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi para hadirin sekalian. Terima kasih telah bergabung di acara webinar Reality Modeling Webinar Series yang bertemakan Context Capture the World's #1 Enterprise Level 3D Imaging and Point Cloud Processing Software. Jadi selamat datang para hadirin semuanya. Kali ini kita kedatangan dua tamu. We have two amazing speakers. That first, let me introduce them. We have Mr. Joseph Alyong, Action Lead Digital Cities Bentley System from Singapore. How are you, sir?
Hello, thank you very much for having us here today.
And the second speakers, we have Mr. Mark Ridman, consultant in geospatial industry in Australia. How are you, sir?
Very well, thank you.
Okay, it's a great honor to meet you here. Dan tentunya maybe we use a dual language, bahasa and English, because our participants from Indonesia, you're using bahasa. And then terima kasih juga di sini kita kehadiran Dekan dari Fakultas Teknik Sipil dan Perencanaan ITENAS, Bapak Dr. Sony Darmawan. Selamat pagi, Bapak.
Selamat pagi, selamat pagi.
Ya, dan juga di sini ada Bapak Dr. Teh Indra Nur Hamdan. Selamat pagi, Pak Indra.
Selamat pagi. Good morning.
Oke, baiklah. Untuk memulai acara ini, mari kita dengarkan sambutan dari Bapak Dekan Fakultas Teknik Sipil dan Perencanaan ITENAS. Silakan, Pak Sony.
Ya, terima kasih, Bu Rika. Ya, good morning, everyone. Maybe I will speak in double language, bahasa and English. Oke, first terima kasih banyak untuk para peserta, our college in ITENAS, other university, also from the government and industry, also the honorable keynote speakers and all participants. First of all, I would like to thank you for the committee, Dr. Indra, for giving me a great honor to deliver opening speech, sambutan in this activity. This is very good opportunity. Also for the speaker, thank you very much, Mr.
You're on mute, I think.
Excuse me, Dr. Sonny, you still mute?
Very sorry. Maybe I will repeat my opening speech. Okay, good morning, the Honorable our colleagues in ITENAS, other university, government, and industry. Also, the Honorable keynote speech and all participants. Terima kasih banyak. First of all, I would like to thank the committee, especially Dr. Indra, for giving me a great honor to the delivery opening speech in this good opportunity. Also for the speaker, Mr. Joseph Alyong from the ASEAN Lead Digital City Bentley System Singapore, and Mr. Mats Ritman as a consultant in the geospatial industry Australian. I'm very appreciate you can coming and as speaker on this event. On behalf of the host on the webinar, with topics very spectacular about the contact capture, the world #1 enterprise level 3D imaging, and point cloud processing software. I welcome you all and thank you very much for coming today. I believe on this webinar, we can discuss most recent technology and also application to exchange innovative idea, experience on the promote future research on 3D imaging and point cloud processing. I'm as a Dean Faculty Civil Engineering and Planning will support all research, also project activity, improving science and technology, also open to collaborate between our university and with your institution. And finally, I'm sure in this event we'll get a lot of advantage. It can improve our understanding, especially about the 3D imaging and point cloud processing, and also enlarge your networking. Yeah, please do participate in this golden opportunity. Hope this webinar will bring some benefit and also hope everything goes well. And please enjoy. Terima kasih. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Bapak Dr. Sonny Darmawan. Baiklah kepada para hadirin, nanti akan ada 2 sesi untuk pembicara. Yang pertama akan dibawakan oleh oleh Mr. Joseph Alyong, and then the second akan dibawakan oleh Mr. Mark Ritman. Dan di sesi tersebut akan ada sesi tanya jawab. Nah, untuk tanya jawab silahkan Anda untuk menuliskan pada link yang akan disampaikan di chat room nanti ketika acara, dan juga di akhir acara akan ada pembagian sertifikat. Tentunya jangan lupa juga untuk mengisi absensi, bukan absensi ya, tapi presensi di acara webinar pagi ini. Terima kasih. Okay, let's for the first speakers, please welcome Mr. Joseph Alyong. Mr. Joseph Alyong is Asian Lead Digital Cities Bentley System Singapore. Please, Mr. Joseph, the time is yours.
Okay, thank you very much, Parika. And also thank you to Pasoni and Dr. Indra for having Bentley giving us this chance to present in this webinar. I see that they have quite a lot of audience here, so thank you all for coming to attend as well. I'll go straight to a very quick introduction, and then I'll hand over the time to Mark. Basically, in the world today, we have a lot of emphasis on digital twins and digital cities. Now, Bentley has embarked upon, offering solutions to the industry since many years ago. And the idea of the context capture, as you're going to see, actually came about through the acquisition of a piece of software back in 2005 or 4. And from then onwards, we have been contributing to the change in the industry, whereby we are offering, very, very high performance photogrammetry mesh model creation. Now, all these mesh models and the point clouds that they generate are actually contributing to, the context of any digital twin, any digital city, or even an asset or an object that you need to manage, today. And especially in this few years, you can see around the entire region in ASEAN, there's a lot of emphasis on smart cities and digital twins and so on. We have platforms that offer these solutions for example, local governments, federal governments, large campus operators to actually monitor their facilities and so on. And Bentley offers a complete suite of solutions for data production, as well as management and analysis, and also for collaboration and sharing and so on. So today we're going to focus mainly on context capture. And Mark here is really a very, very experienced consultant in Bentley. He's more than 10 years, like 14 years in Bentley, managing all the GIS and the reality capture models, modeling software solutions. So he's the right man to give you the introduction to context capture itself. So I'm not going to speak much longer, and so I'll right now hand over the time to Mark. So thank you very much.
Thank you, Joseph. Yeah. So let me share my screen. So I need to do this in English because my Indonesian is, let's say, not so good. So if there are questions, somebody can maybe translate it and help me with it. So today what we're going to discuss is what Joseph said, more the context capture part of things. So what is reality modeling? So what is it in general? The most important step, what I think, is how to capture the data. So we're going to do global, not too much in technical detail, but tell a little bit about how to capture data, what devices you can use, some basic rules so that you can understand a little bit that it's not really complicated, but it is something you really need to pay attention to. And then we're going to go in the models. So I've got a lot of different type of models for different type of objects for digital cities, for but plant sites, how the police using it, iPhone models. I'm going to go a little bit through some models, how users are using our software. And then I want to show, if we still have time, to how to use the model. Some applications where you can use the model, and it doesn't have to be in Bentley, it can be in Bentley application. So there's a little bit agenda from today. Well, before I start with it, I want to show you one screen. So this is what we call our portfolio, our playbooks, what we have. So you see, for example, Bentley is a big company and we have a lot of software. So for example, in the wastewater industry, we have software, we in mining, in roads, buildings. But what the funny thing is that almost everywhere you can see context capture coming back. So if you do power plants, you can use context capture. For subsurface utilities, you can use context capture. So it's a quite interesting area where we're in. So normally I'm a land surveyor, so I'm in digital cities teams. We do more the city modeling type of stuff, land survey. But last couple of years, I visit the Shell and the BPs and the police. So it was a quite interesting environment. That's why I want to show some different type of models so you can get ideas how you can use that reality modeling. So it's not only for a surveyor, for example, building up a digital city. It's way more. So what is reality modeling? I'm not sure if you can see my screen. Got the thing there before. So it's a technology where we can really quickly produce 3D models. Reality, we call it reality models. So there are mesh models. And if you see what type of devices we can use for input, we can use cameras under a plane. So if you want to do big city modeling, you have a special camera where you can fly over the city. Certain type of cameras, you can produce models. You can use drones. That is more in general for the smaller, for the normal models is created from drones. And it can be an Mavic Pro 20 megapixel, can be also an M600 DJI with a 61 megapixel or 100 megapixel camera. And then we see a fixed wing drone, so large areas or mine sites. For example, the Wingtry is a popular one, so vertical takeoff and landing drone. And then also just digital cameras, handheld. So walk around creating high resolution models and combine it with drone if it's needed, or just have the model itself. Things from the phone. Mobile laser scanners, so road modeling, for example, what the users drive on the roads. They create a 3D point cloud, maybe 360 images, and then we can process that also. So basically, the way it works, you have photos captured on a certain way. You put it in the software, and then you can use it, for example, for mapping, for asset inspections. That's a big thing nowadays with cell towers, for example. Construction monitoring. So what you want to do, you want to have a construction site, and you have to, for example, you have to pay the contractors on work that they deliver. So if you create a model, you can check if did they already finish their work or did they not do it at all. So construction monitor, and also building up a history of your object. So you have different models over time. So if something happens, for example, for insurance or just for inspection, you can pick up that model from a certain data and you can view the data, how it was back then. Digital twin, of course, and then way more applications, what I said in the beginning. In the design phase, for example, you want to, if you design an object, you need to understand what you already have there. So understand the existing conditions. Risk management is, of course, a big thing. So you can do the design on the mesh model. In the construction, what I said before, change detection. So is the model really built like what the design was? Document the construction site. And if you go in operations, you can do training and simulation. And later we're going to show some models, for example, how to use it in a HoloLens. We can do virtual inspections and asset management. It's more on the side of the operation. So how works the software? So what we do, we create photos, and what's important is, and we discuss that a little bit later also, is the overlap from points. So we can do something like this. We can do statue. People is quite difficult. I will explain that in a minute. But you walk around an object. If you do it with a handheld camera, capture something from different angles, different rotations, and then you can model it. Same in a drone. We have a lot of different type of drone capture guides, and all depends on what you want to model. So if you want to do an asset inspection, for example, on a cell tower, is a completely different way of capturing than if you do a train just for mine site for volume calculations or for design. So that's an important thing to understand, and I hope that at the end of this session that you get it, that it's not rocket science, it's not really complicated. You have to follow certain rules. to get the model, the output that you desired. So that's an important one. You understand the output first, and then when you understand the output, you go back to what camera can I use. So if you don't have a need for a high-end resolution mesh, you can use a less camera and cheaper camera, or you fly higher so you make less photos. So that's all things that you need to consider. And this is, for example, if you do a city modeling. So we had one of our users recently did city, Singapore, where they fly around with a certain overlap, certain angles, and they create a mesh model out of it. So again, some examples, what devices you can use, and then as an output, you get a mesh model. Again, on the acquisition side of things, you need to understand how the software works. So basically what we do, we stitch images together based on common points. So, and on RGB values. So it's important that you have a texture in the model, and every point that you want to model needs to be in 3 photos. So it's important to have a lot of overlap. So if you see holes in the model, quite often it's because there's no data, or a bad texture, what we come explain in a minute. And also the capture technique defines the quality of the model. So you can imagine if you, for example, on this side, Q point 3 photos like this is maybe not as strong if you then also have photos from the other side, high and low. So that makes the capture technique can make the quality of the model also stronger. So what we do 3 steps. We have a process we call aerial triangulation, where we import the images, we extract key points from it, and then start matching the images together. And when we have that, we're gonna do, compare points to points for stitching, and then at the end we do create a mesh and texture out of it. And then from context capture after that, we can export to maybe a lot of different type of formats. So we can do the Bentley formats, the open formats, as OBJ, Collara, Lot3, but also industry specific. Like if you use S3, for example, i3S or FBX for Autodesk. And then we can also create a point cloud out of it, the mesh, and also orthophoto, of course. That's normally the main product for a lot of users still. The limitations of photogrammetry is moving objects. So that's why I said in the beginning, people is difficult. So if you model people on street level or so, it's really hard because people are moving. Even if they think they're standing still, they're still moving. So if for example, somebody moves his arm, then the arm is not modeled, so it's no arm. So if you want to do people, then normally you build like a camera rig system where they have a lot of cameras and they press one button and all the photos are taken at the same time. Another problem is transparent surfaces, things like glass, shiny objects, because what I said before, we compare pixel to pixel. If it's transparent, we can't really compare it. So you see glass issues. So we have ways to work around it and make it better with different type of capture technique, and we can also clean up the model if it's really, but it's more manual process. And another issue what we have is there's no texture, poor texture, or no texture at all. So if you do, for example, inside buildings and it's really nice, shine white buildings, it's really hard for us to model it. And that's where in average the point cloud comes in. So if you have that in that case, you can combine, you can create a scanner, and then you can merge the handled images with that, and you get a better output. What's really important to understand, and I already can't say it often enough, the output really depends on the input. So bad data in is bad data out. That's with everything, but with context capture, with this type of software, you can really see it right away. So if you capture data, at least what we need is a 70% overlap. So we suggest even more, like an 80%, but that depends a little bit on what the capture technique is. So if you do 80 images, you're shooting vertical down, at least 70% overlap. So you can do less. I did some models, for example, when 60 and 40% overlap, the traditional survey images for historical mapping. So government users have a lot of data. They want to create ortho photos or 3D models out of it for archive purposes. And then we can use context capture also for that. But if you have less overlap, that's the model. Looks not really that great, to be honest. And what's also important is fast and together is that angle difference between points. So we compare on pixel to pixel, but a pixel is not a point; it's a flat surface. So you can imagine if you have a point here, the flat surface on this image is different from that image. So if that angle is too big, then the software can't really stitch it together. And that's all things that it's experience, but there's also something we can help with. We have a lot of different type of capture guides, and we can guide you through that process to better understand that issues what you can have here. So with the capture, some examples. What you try to do, for example, you see here the car on this side. What we do, we walk around, and it doesn't really matter if you do the inside or the outside first, but let's say you do the outside here. Try to keep the same distance to the object. So don't capture images, for example, this one, and then you go in and go out, shooting the other side. Try to do a little bit the same order. Then the software is easily for stitching the images together. What an issue can be is this distance between this object, for example, an object here, the resolution difference. So if you shoot from far away and point, let's say, is 5 centimeters, from close by is 1 centimeter, the same point, but we can't recognize it. The software doesn't recognize that it's the same point. So what you need to do, you need to get some steps between. And that is, for example, with this car example, but it's also quite often with buildings. If you fly really high, let's say you fly, 100 meters with a Phantom 4, if you then go down to 30 meters, then the software can't stitch these images together. That is a way to do it manually, but you try to avoid manual steps. But if you do, for example, buildings, the best capture technique is still orbit around an object, going around shooting objects from different angles. On the building side, I think that angle difference, what I tried to explain before, that 15-degree angle difference is really important if you go also around corners. So if you go around a corner here, if you don't make enough photos, we can't stitch this together. But this one, small steps, small angles, then the software can stitch it together. And also important to understand with photogrammetry in general is what you do is, for example, if you want to do this building, you have to make small steps. So you shoot photos basically straightforward, but you can do a little bit left and right. And of course, you also need to make sure that you have an overlap vertical. But what you don't want to do is make for example, stand here, shoot images all the way over there, and then you go on this side and do the same from the other side. Then the software can't really stitch these images together. And again, some of the setups what we see the users are doing. I mean, I will show later a model from my iPhone. You can really good models out of from an iPhone, because you can come really close to the object. And then the normal digital cameras, and then some different type of drones we can use, and then the special cameras what's under a plane. So the capture, considering the time is quite quick. I mean, this is something normally we can do in a 1 or 2 hour workshop or training. There's so many different capture techniques and different ways what you can use for capture something. So that's something that depends on a lot of factors. So that's something that maybe we can do that separately if there is more interesting. What I want to do now is just want to show some examples, so from models. So I got some videos where I got these models also live, so I can also show it live, maybe show some models live considering the time. So this is a city model from one of our users, Aerometrics. So Bentley bought Accu3D, the French company, in 2011. This user already was using it before it was Bentley. Of 2015, we bought it. The software started in 2011. So I think they already started using it in 2012, I think. So they are really experienced. So I think one of our best users doing this type of modeling. And then when I start playing the video, you will recognize why I think that. So first of all, what you notice that you hardly see any cars in here. So what they do, they process the data and then they take the data out and clean it up and then reprocess it again. So that's a step that is quite manual and time consuming, but that makes the model way better. So if you see the quality of it's more on photo than I think a reality mesh. This one is also available online. So if you Google Aerometrics and Bendigo or Pau in France, there's also one of the models. They have a lot of stuff online available. So the way they capture in general is with helicopter instead of with a drone. So it's easy to get access above cities with a helicopter. So you just hang out of the helicopter, shoot a lot of images, and then handheld capture. So you can use devices, for example, for mounted on a car. And in general, Aerometrics is just walking around with the handheld cameras and shooting on a certain way, and then later merge the two data sets together. Yeah, so this is quite a long video, so I'll break it off. So you can view it online if you want, if you Google it. So another example, this is one of our government users. What they do, they have a model here from a heritage building in New South Wales, and they use a Sony A7 Mark III 42 megapixel camera with a DJI M600. So a really high resolution model. And what they are using this for is for brick replacement. So they want to do inspections off-site from the brick, and then if it needs to be replaced, they can measure it. It's really scaled. They use a lot of ground control points for scaling. And then they can just prepare the data off-site and then bring it on site for replacing the brick. So this is a little bit more high-end model capture. Got different of. This is quite common for a lot of these heritage users to get a quality like this, and also even doing it inside the building. So this is another example how users are using context capture. So this is a model created with a camera rig. So we have 5 cameras on a drone. So you fly just up and down like a normal nadir flight, but you shoot 5 photos at the same time. So 1 down, 1 left, right, forward, backward. So that's a camera rig model. And this is, in this case, you can see it on the right top. It's a 5 times 24 megapixel camera. And they're flying 105 meters high. So the GSD is less than 2 centimeters. So if you want to do city modeling, you can do it with a single drone with a single camera, but then it takes you way longer. And of course, there's more risk here. Something you forgot to capture something. This is, with a camera rig, you have less chance to forget something. But also, the main thing is you do it basically at the same time. If you do it with a manual camera, you have to fly it forward, backward, left, right, and do orbits and that kind of stuff. And the shadows will really move. So you see really hard shadows here, the colors. And that is the advantage of doing a camera rig. You basically capture it at the moment that it is. You don't combine different times of the day with the one model. Another use case is it's really popular at this moment is doing cell towers. So for inspections, you need to climb up and do inspections. You have to turn the tower off. You need to be with 2 people, at least in Australia. And then a lot of parts of the world is just too expensive to do it all manually. So you can fly with a drone. This is done with I did this one myself with a Phantom 4. And 1400 images fly around different angles, you get a model like this. So yeah, this is something that we are really good in with the software. We optimize the processing, so we can do in less than 10 or 11 hours processing, we get a model out like this. Another use case is doing plant sites. So this is an example from a combination of drone and handheld. So this is something that the user fly with a drone, and I was on site. I captured the data with a handheld camera and we merged it. So this is really a digital twin example, but the user in the office, they need to see, read this kind of numbers and also tags on the pumps. And they don't really need the high quality model all over their over the plant site. We only do the objects that they really need. So that saves processing time, capture time. This is an important thing. But if you want, we can do the whole plant on this quality. So let me take a second to zoom in. So you zoom in, you see, you can read what's on that object. And this is really a digital twin example that people in the office wants to see what's there. We can attach sensor information here, or the information of the pump. So if you click, you can see the maintenance forms. But there's a combination of drone and handheld. So flying drone, flying a handheld, capturing data with handheld, and combine it. And there's a certain workflow what we can help you with to train. It's not so complicated as long as you can see points in both objects. It's important to understand. So this is an example of a user who never fly in drone before. They did it with a DJI Mavic Pro. He fly in drone, but he never really captured data. So this is his first model, and I was quite impressed with a Mavic Pro 2. So 20 megapixel camera and doing a bridge for asset inspection. So we see a lot of high-end models on bridges even underneath the data out. But yeah, this is just with an relative cheap drone, small one, not so special. But the advantage is the camera is like facing forward, so you can even shooting up. So what you see, the green stuff is a little bit noise, but I should have removed the data. So I processed it for the user, but I didn't remove the data. But that's something that we normally would have done is clean up the model, remove objects that you really don't need, and it looks quite nicer. But yeah, I think it's quite impressive for just a Mavic Pro doing bridge inspections on that side. So in Australia, you have a lot of rules for health and safety. So capturing this with a drone, it will save a lot of money and time. Yeah, something like this. So you don't really need an 42 megapixel camera to create a really good model. This is another example. This is, for example, from a mine site. So this is done with an Wingtra, so the fixed wing drone. So they're flying in this case, what is it, 100 meters high. But this is only in camera facing down. So the sight of objects is really not that great. So what I show in this example is that you can do, for example, you can measure distance. So this is just in a context capture viewer. So you get with context capture and free view, and you can also give the viewer to everybody can use it. So you give a model and they can download the view from our website and can use it. We can do things like simple volume calculation, for example. So you see something like this. So just in a viewer. For mine sites, we also see a lot of use cases for users doing geotechnical inspections. So if there is an accident on the mine, the rock came down or something, the geotechnical people want to know why. You can create a model, high resolution model, so they can measure angles and that kind of stuff. So this is was a little bit more playing for me. So this is this is the area where I live, is in the Gold Coast in Australia, and this is also a university. So what I did is we don't have high-end mesh. I went in Google Earth. I created print screens basically from just Google Earth and put it in context capture. So if you, for example, this is for students from this university, they do some modeling all over the areas, and they don't have an overview project, so they have a small, let's say the building or so, but they want to fit it in a real environment. So that's something we can do now. We can create from Google Earth. We can create a model like this. It's not the best resolution, of course, and then you can merge it with, for example, with a high resolution drone model. So we have a more overview. It's cheap and easy to do. And I tried to do a Google Earth model from Bandung, but the Bandung in Google Earth is not in 3D. So there are only some buildings in 3D. So it really came out really well. Another thing is things with the iPhone. So this is that same university that's near my house. So what I did is I was walking with the dog, and with the phone, we just captured some images from one of the models. So this is just for the iPhone. Originally was not georeference, but I use some scale constraints or measure certain objects, and then you tell the software what the distance is and then reprocess it. And you get the model is then scaled. And that's just with a phone, nothing special, just walk around shooting photos with a certain overlap and different angles, and you get a model out. So yeah, from this one, I don't have a model, but I think it was really interesting what one of our users did. They use software from Bentley that's called Gins. That's for boreholes. So what they do, this is for road modeling. So they want to extend the road. So what they do, they open a certain area, they go in with a model. And they do, you can see here, they have measurement things where they start calculating this type of stuff. But what they do, now we create a context capture model, create a side view and load it in that software so the user can see on geotechnical side how it is in reality instead of just numbers in the software. I think it's a really interesting use case. Considering the time, so if somebody wants to see another type of model, I've got more models what I can show. Otherwise, we just show some examples how to use the data. So this is another piece of software from Bentley. It's called Open City Planner, and Open City Planner is more is a cloud-based application, but we can also combine, of course, mesh models, but it's more for city planning. But we can combine different data like design models. We can put if you design a road, for example, we can put that in the software. And this is also really good for user engagement. So this is a mesh. This is Brisbane. So you see, we have a mesh model from Brisbane. There's an Australian company, Nearmap. And is it not playing? Yeah, flies whole cities or whole areas, and in Australia and the US. You see what we do, what we can do with the software. We can flatten down a mesh, so you have an existing mesh, and then we can add a new project to it. And then in this case, what we did some information about what the project is. But if you see, if you turn it off, it's and then we have zoom views. We can guide users to process. So we have zoom locations. You click on it, you can do shadow analysis here. For example, this is then for city modeling, but we have many use cases for Open City Planner. It's more our front end for digital twins. So you can do measurements, of course. So this comes from a Scandinavian product, the Agency 9, what Bentley purchased, I think, 2 years ago. And so in Scandinavia, there's a lot of cities are using this. And for the city modeling, what you can do, for example, if you want to ask your users, the public, from what model they like, you can have multiple models at the same location. User can turn it on, turn it off, and then can even have comments, can information if they like the model, or which one they like, for example. And because shadow analysis, you can, yeah, of course, make the sun come up or disappear. So this is opacity planner. This is also opacity planner, but this is for city of Helsinki. So they combine it with some other data. So with GIS data, for example, here, so you can doing things like web services. You can load data from a spatial database, but we can also load data from another application from Bentley. That's Orbit. So Orbit is a point cloud viewer. So this is data with a mobile scanner with 360 images. So we can link it, load that data in opacity planner. So the user has one interface for seeing all the information he needs. You can create portals. So if you, let's say, you can have whole Indonesia, you zoom into a certain object and then it load that project from that city. This is like what we do here as a portal. So you like the portal, you can turn, for example, a model on. There can be a Revit model. It doesn't have to be a Bentley product. So this is natively reading Revit models. And then you can have some information about that project. So this is also, and we can use this as an interface into design modeling. So if you have other applications, you can click on it. You see all the design data from that object here, with all the attributes, etc. So you use it more as an interface to that object, to finding information about certain objects. So this is Orbit itself. This is the Orbit viewer. So Orbit has different applications. So one of them is feature extraction. So we can load on point cloud. We can do automatically feature extraction. Something we can do with machine learning semi-automatically. But this is the viewer bit. So this can be on the cloud, can run in your own cloud, in your own environment, and we can combine 360 images, point cloud, mesh models, auto photos. The user can have comment, for some you can do annotation. So if you want to place an object here, so let's say I want to place an object here, you can do it from search from a library. You want to place an object, and you can view that object then in the different sites, and then users can have comment on it, can create print screen, share it with other users. So this is more a technical viewer than, for example, OCP. This is a little bit more complex, but it's more for the technical users probably. So you can create a snapshot and then share it with someone. So this is the Orbit Cloud Viewer, and then in this case we also can load the mesh model, and then you can combine the data. So the Orbit feature extraction tool, what I just said before, this is also an interesting one. You can load your mobile mapping data or your static point cloud data. And in this case, if you want to do automatic traffic pulse detection, it can it's fully automatically. Because you make it a little bit shorter because it's a heavy project for your graphic card. But then you can identify what type of object you have, and you can do modeling from the lines, roads, that kind of stuff. So this is the Orbit feature extraction tool. That's a part of the Orbit product line. Another interesting one, and this is really simple model examples. This is concept station, it's a conceptual road design. So this is already 2 or 3 years old. We did a webinar at a golf course, and we captured with the drone some data, and we gave it to my colleague, and he designed on that area a roundabout. So you see, you select an area where you want to work, set things like coordinate system. So this is in Australia, so Milk Australia. And what he does, we can load that model that we created. So this is a really simple 2D of, yeah, a little bit more name, but let's say an idea capture. He loads it in, and then he starts doing conceptual road design on top of that mesh model. So you see here the 3D mesh model. And then based on a library, what we have, we can add type of roads. And this is, I'm not sure about Indonesia, but for most of the countries, we have these libraries. We can select what type of road you want to place. Profile, and then you select an object. You select basically, you snap to it, and then it creates that road. And now in this case, he wants to create a roundabout there. So you have to make another road towards, in this case, the golf course. So do something like this. And now he said, so they are now connected. And then he said, okay, I want to create a roundabout with, you give the certain values that you have, and then you place it, connect basically both of them together, you get your roundabout. So this conceptual road design, we can also give an estimate price what it's going to cost there on earth volumes, for example, and then distance from the material, but this is all in 3D. So this is overall concept station. So this is, and we can also, of course, load the data in our design applications like open roads and open buildings. Yeah, another use case. This is not an application from Bentley, but it's a Siemens application where you can do virtual inspections, where you can, yeah, basically walk through your plant. So I think it's Cosmos or Comos, so the application where you can walk around. So this is a mesh model created with context capture, and then you can walk around seeing objects, select objects, even see attributes from it. So you see, if you walk around and click on an object, you can see what it is. Let's see, yeah, walk around. So this is an external application. So you can see, jump to certain points, see information about objects. So this is what we do a lot nowadays, creating reality mesh models from plant sites, some similar like this, with different camera systems, handheld camera rigs, for example. Yeah, this is another Bentley application. This is a HoloLens, so where you can load your 3D mesh model in a HoloLens. So this is in the office, where you can view through the model, can do inspection. So this is already an application what Bentley is already have available, the HoloLens. You need to have a HoloLens, of course. We have also some movies online about what we do, really high-end bridge inspections with this type of with an HoloLens. It's really cool. Somebody standing in the kitchen and you jump to the bridge and you see you're in the bridge, basically under the bridge. On the cell tower applications, we have an application that's tower side, where we load a mesh model and can do machine learning on the mesh model. So I don't really have a movie from it, but that looks like this. This is the portal where you can load your mesh model, and we can do things like antenna detection. We can link original images. So you click on the mesh model, you see the original images with the information about the antenna. So we are developing our AI, but it also comes available in context capture. So you can do basic antenna detection in the next release from context capture. So you create a context capture model, then you run that AI, what comes with the product, and you get a result like this. This goes a step further, where we detect what type of antenna it is, and you can even remove one of the antennas and replace it by something else. But in the next releases, we do more with machine learning, road detection, and then we can even do building detection and so. So this is what the stuff that I wanted to show from context caption. I hope that I stayed around in the hour. Are there any questions, or do we want to, users want to show another type of models? I understand this is a high level, so there's we didn't really go in the software and so on, but.
Okay. Yeah. Thank you, Mr. Mark. How about we continue to the QA session, or maybe we can continue to Mr. Joseph's speakers?
So actually, hi, thanks everybody for, that was a very, very, informative talk for about 45 minutes, Mark. I mean, we've covered a lot of things. Huh? In fact, Mark also covered 2 other technologies, which one of them is Orbit and then the other one is Open Cities, right? And, we are through those, like the 3 that we have covered today, Context Capture, Orbit, and Open Cities. We are actually the only ones in the world today offering the complete suite of solutions for you to, and even more than that, even like, for example, the roads, the buildings, and so on and so forth, all the applications. We're offering the complete capability for any infrastructure owner or any government or any ministry to actually have a complete end-to-end solution, from visualization to management, operation, design, you name it, for the advancement of the infrastructure, basically, right? So I'm curious, if you don't mind me engaging the audience a little bit today, how many of you here are sort of, I believe there are students here. I think there are also private sector, commercial participants as well. Maybe how many of you are from the ministry? Maybe you can type ministry in the chat box so that we know, how many of you are keen to explore a little bit more about, public works, for example. Do you mind? I mean, just you can just put in the chat box and say, oh, I'm from public works or something like that, how many of you are from public works? Maybe you can just type it in the chat box so that at least we know, your level of interest, and how many of you are from, how many of our students? So maybe you just type in students, then at least we will know, roughly how many of you guys are, academics and so on and so forth, And then we could, I mean, if you don't mind me suggesting, then at least we know, what level of audience that we have. And then, and how many of you are maybe drone operators, for example, right? Are any of you drone operators? Do you own drones? Do you fly drones for projects, right? What kind of problems do you face when you are flying a drone, right? One of the things that we didn't really mention about was that, context capture can scale on the enterprise level, right? So we actually have a cloud version as well, that you could actually have multiple engines running, right? Or you could even have it on your premise, on-premise, to have multiple processing engines running as well. So the system can scale, and it's really processing pretty fast. Okay, so Ibu Rika, maybe.
Okay, I'm going to translate it for our audience,
Yeah.
Baiklah, Bapak Ibu, mungkin dari Bapak Ibu ada yang dari instansi pemerintah atau dari perusahaan. Silakan untuk memperkenalkan diri di chat room. Misalnya saya Gusti Ayu Jesi Kartini dari ITENAS, I'm a lecturer mungkin, atau mungkin bisa yang lainnya. Nah, apabila mahasiswa, silakan untuk memperkenalkan diri. Saya student, apa misalkan dari perusahaan, mungkin ada dari perusahaan yang konsultan geospasial yang di bidangnya itu adalah ada project drone dan lain sebagainya. Mungkin tadi ada pertanyaan dari Bapak siapa di chatroom, saya lupa. Nah, silakan untuk memperkenalkan diri di chatroom bahwa saya dari konsultan ini, atau misalkan saya dari perusahaan ini, saya dari instansi dari BPN, atau misalkan dari PUPR, silakan. Atau misalkan saya mahasiswa dari ITENAS. Silakan untuk memperkenalkan diri di chatroom. Or maybe, we have a lecturer that he is he's a photogrammetric lecturer. Maybe I will introduce you. We have Bapak Harintaka. Assalamualaikum, Bapak Harintaka. He is a lecturer from UGM, University Gajah Mada in Jogja.
Oh, hello. Yes, hello. Hi.
Apakah Bapak Harintaka sedang on?
Joseph, this is Sri from Bentley Institute from Melbourne.
Oh, hi, Sri.
How are you, Matt? Sorry, on Zoom, so I'm trying. I don't have the Bentley background on the Zoom because if there are students and professors who could be interested to go into further journey on context capture reality modeling, Bentley Institute, which I work out of Melbourne and take care of Southeast Asia, we would be more than happy to work with them. One, to provide them access to the reality modeling tool, our context capture tool. Two is that to give them access to on-demand learning content that are available for them so that they could go on a video form. Of course, most of the learning is in English, unfortunately. Three, if they need some kind of a hand-holding or virtual session, we would be more than happy to work on, because Bentley Institute is a part of Bentley systems, and we cater to the needs of the education market in the form of university teaching staff and the learning community in the form of students. So we would be more than happy to find out how we can work on that, and either Joseph or Mark can come back to me on that. So we would be delighted to work with that. In the sense, we can provide them, all the students, possibly a limited period of access to the software, which they can download onto their personal computer and work on doing a project on, and to the learning content. Do it make sense?
Yes, absolutely. So thank you for coming on, Sri. In fact, yes, ITENAS, and we've another university here as well. And I believe we have a lot of students here. So I will also link up, Pak Indra. Please meet Mr. Sri Kotir from Australia. He's our representative from the Bentley Institute. And also Pak Soni, who was here just now. I think he's still here somewhere. We will link up, and I think the university can actually coordinate with you, and then so that we can get all the required scheme and licenses and so on. Absolutely no problem. Yeah, that's fantastic. Thanks for making the offer.
Thanks, Joseph. Appreciate that.
Yeah. So that actually answers the question. There's a question here from. Oh yeah, okay, that was you actually, Sri. to say that, to talk about the licensing.
I think it's on. Can I show you a little bit of a question from audience?
Yes.
So we have here from. I don't know, he or her.
Mm-hmm. Yeah, I know.
He said that when I have processing the corridor data, why the result is curved.
Yeah, that's quite often the capture technique. Or the capture technique or the camera calibration. So in the later releases of context capture, you can handle it way better than before. So, but it's always tricky if the camera calibration is not correct. Fly high and not enough fly different flight paths to each together. But something, yeah, we improving the area triangulation bit, but quite often is a camera calibration issue.
Okay, maybe next is we have from Jesse. On your one of case study, you said that this work combined drone and handheld. Could you tell us how high the resolution and how high the accuracy, maybe in number?
Yeah, I can't really. I mean, it's in the range of 5 millimeters. The resolution, something like that. In this case, we didn't use a lot of ground control points, so accuracy is maybe a little bit, yeah, also similar, I guess, around a centimeter. But we did some other project where I unfortunately can't show this model. The plant users don't want them. We show their models, but we get a really higher resolution and a high accuracy, even higher than the model I showed, because we often use a lot of ground control points. So it's really accurate. Yeah, it's in the range of the point cloud if you think about that.
Okay. So we have Bima. Is there any minimum requirement device specification to run the modeling software?
The hardware specifications.
Yes.
Yeah, so the context capture uses two type of processing resources. So the area triangulation bit is a heavy CPU bit, so a good CPU will help, and a lot of memory. So if you have like let's say more than 2,000, 3,000 images, you have to go to at least 16 gigabit RAM. We advise to use 32 gigabit RAM minimum for larger projects. The other part is the producing of the model itself. There's a heavy CPU bit. So if you have hardware that's not so good with not a good graphic card, so we use a combination of a high-end processor with a high clock speed. So we want to prefer i7, i9, something or AMD. But if you combine it with a graphic card that's not a gaming graphic card, so let's say the P2000 or so from Quadro, then it just takes you longer. You can still process, but it takes longer. So for example, on my machine, I've got a laptop with a Quadro P5200. I can do around, depends on the type of project, 30 to 40 gigapixel per day, while we have users with high-end hardware with a really desktop computers, we can do 70 to 80 gigapixel per day. But we have also users with a bad graphic card, we can do 10 or 20 per day. So it's not really a minimum, it's more what budget you have and how quick do you want to have the model.
Okay, maybe last question. Can a camera with a poor resolution be able to model objects in detail with the help of Bentley software?
Yeah, so basically it's the distance to the object to define the quality. So if you have let's say, I think the lowest what I did is a 5 megapixel camera, but then you have to go really close to the object. But things like a phone, if you can come close to the object, you can do really good models. But yeah, what's poor resolution? Nowadays, almost every phone has already almost 10 megapixels. So yeah, I think there's a little bit standard.
Okay. Well, thank you, Mr. Okay, thank you, Mr. Mark.
Welcome.
Maybe we can continue, Mr. Joseph.
Yeah, I need to drop off. Sorry for that.
Well, I think that sort of covers most of it actually. In fact, we have. I mean, Mark has also covered the orbit technologies and also the OpenCities platform as well. Maybe if the audience would like to talk about what their requirements are they embarking upon any projects soon or something like that? On the academic side, I think we can arrange with Sri to get the licenses for your university. And if there are any other types of projects and so on, we could either take it offline or can ask general questions over this forum. And I understand Mark has to leave this webinar. And so thank you very much, Mark. It was certainly a very, very insightful and, a lot of content that has been, conveyed to us. Huh?
Yeah. But we can do this for 2 days in a row. But
yeah,
it's so interesting stuff. Yeah.
Unfortunately, Mark is engaged with currently in the customer's office. Actually, I understand.
Yeah.
And so I think he has to sort of end his call soon. Yeah.
Yeah. Okay. Thank you.
So thank you, Mark. Thanks a lot for your time.
Oh, no problem.
Thank you.
Thank you very much, Mark.
Bye.
Thank you very much, Mark, for your time.
Yeah.
It's a nice presentation.
Yeah.
Thank you. Bye.
So, for those remaining here, we do have quite a lot of content. A lot of the content that Mark also presented is also available on some of the YouTube channels that we have. And what I can do is I can share it with you really soon. I'll put it in the chat box. One of the things that we are trying to convey as Bentley is that the solutions need to sort of work together, right? In order for you to have a very successful implementation, because to capture an object, for just to capture the mesh itself, is not the final outcome, right? The final outcome is really about creating a tool or a visualization mesh so that you can make decisions upon it, right? So that you don't have to travel on site, right? Because of course nowadays with the COVID, that reason is even more important, that we capture a model, right? For example, the bridge, and as you can see, the plant and so on and so forth. And then we put it online so that people don't have to come together. They don't have to travel to the site, right? They can look at the quality, the state of, let's say, the bridge, the bricks of the house, and also a very good example are the telco towers, right? Because many of them are quite high, tall, and the antennas actually sit where you don't see them from the ground, right? And you want to inspect the condition. And so in the case of telco towers, for example, well, the industry is divided into, the mobile operator and the network operator. And then now there's also this group called the tower owners, right? And when the tower owners build a tower, normally they have, more than one, they call it a tenant, who is actually renting the space, right? In the tower space itself. And right now, for this situation where many countries are actually rolling out, 5G, right? They have to do an inspection of all the towers, right? So for instance, in Indonesia, maybe there could be, well, I'm making a guess, 10,000, 20,000 towers, right? You just can't say, I'm just going to put a 5G antenna up there, right? You need to know, first of all, where they are pointing to, right? Whether there's space to install the antennas or not, and so on and so forth. So a drone, right, going up there to capture a 3D reality model is not just for the sake of it. It is also to allow you to, see whether there's any more space, right? So that you can actually maybe add a few more tenants, right? onto your tower itself. So there are many applications that you can use. So so I'm just going to add some. You can see here a YouTube video and a series of videos on orbit, right? So so what I'm just trying to highlight to the audience, right, is the capturing of the data is one aspect. Then there's the managing of the data, right? And in terms of the managing, Orbit is a very powerful tool as well, right? And I think, in our next presentation, we might get into a little bit more detail about the Orbit cloud mapping solution, right? Just now, what Mark showed you was the ability to publish and also ability to share the data. And it is not only through the desktop, because the desktop is where you do a lot of heavy lifting. As you know, point cloud data and mesh data take up a lot of memory space. And in order for you to display them and manipulate them, you probably do very well on a on-premise implementation, right? But on the other hand, because nowadays networks are very powerful, and also the cloud computing availability is also very powerful. We run on an Azure cloud, right? And through the technologies of the latest web technologies, HTML5, we are able to come closer to the ability of a web interface to manipulate point cloud data when it's on the cloud, right? So the limiting factor is now not the technology, but actually the bandwidth that is connecting you to the cloud service. Okay, so but we are coming close. We are coming close. So Bentley has addressed both the cloud option, because cloud is really the future, as well as the desktop on-premise type of situation, because many companies and also especially government departments, some of them do not prefer to allow cloud data to be hosted on public cloud. They prefer to have it within the premise. Okay. There's a question here if photogrammetry. So we done is asking a question. Currently, we are doing photogrammetry research for counting in outdoor areas. Maybe you let me know what you are counting. First, we use camera as sensors, and facing that weather is one of potential issues that can reduce the precision of calculation. Is there any suggestion how to accommodate these issues? We done, if you could tell us what you are counting. Stockpile, right? Sand stockpile, right? Weather is one of the potential issues and reduce the precision of calculation. Okay, for sand stockpile, okay, when it is wet, are you referring to the fact that the wet sand is reflecting a lot and you can't capture? Because I suppose wet sand, I mean, that may not be the issue. Why is it that whether wet sand is giving you stockpile errors? Is it because of consolidation? Cloud and ambient of external. Cloud. So are you saying that when you fly a drone, you cannot see through the clouds. We can't handle, see through the clouds and actually form a mesh from, if there are clouds within the image. Yeah. So there's a gentleman by the name of Gatot, Director General of Highway, Geotechnic, Tunnel and Division. Oh yeah, thank you very much. So thank you for attending. I hope you can see that for roads and tunnels, in fact, for orbit, right? If you look at our orbit presentation, you can see that we actually put both above surface and below surface scans and meshes in a single display. So for example, from the surface of the road to the tunnel and maybe through the staircases, you can actually form a complete 3D above and below surface reality model, right? So that's possible as well. So thank you for attending our webinar. So any other questions? I don't mind answering as much as I can. Where I can't, I think we can take them offline. You can, send messages through email to Pak Indra or Ibu Rika, right? He will forward them to us as well.
Mr. Joseph, we have a question here on Slido.link. Maybe we can. I'm going to share it.
Sure.
This is from Bapak Gatot Sukmara. There are 3 questions here.
Okay.
Maybe first, in planning a new road trace, what is the optimum of camera height for topographic measurement, trees height, and water level corrections?
Okay, so it depends on your requirement for accuracy, I would believe, because as a guiding principle, in general, I'm saying, the pixel size represent, of course, the ground separation distance. And when we do the photogrammetry with aero triangulation, the error of the height value generally goes between 1.5 to sometimes 3 pixel error for the height, right? And that also depends on the number of overlaps that you have for a single area, right? So you use the camera resolution, right? And then with the focal length and your flight control software should be able to tell you what will be the GSD, right, that you require. So as what Mark said just now, if you put the camera very close to the object, then handheld cameras can go to 5 millimeters, for example. Well, typically, we've seen drone projects that can go down to 5 centimeters. I think flying quite low. I think perhaps depending on the camera focal length, to maybe like 200 meters as well. That's like maybe like 10 centimeters, depending on again the image, the sensor resolution. I think 5 centimeters is also quite common. So it depends on what your requirement is. Then you can adjust the flying height, right? How to get a complete shape, both above and below of the bridge? Can we compare from subsequent data to find out geometric changes? The answer is, first answer to the question is that you would need then to take the images from underneath the bridge. Okay, so logistically, I think you have to, if it is a tall bridge, okay, easier, right? If you have a drone and you can point the camera upwards as you fly the drone through, then you can, take those images. So I think logistically you have to look at it so that you can take the images in the same manner as how is recommended, right? And how to compare subsequent data, you can do this. In fact, Mark knows a technique. In fact, we have just got a case where somebody was actually taking a crane, an image of a large crane in a container port. I mean, those cranes, they pick up containers from the container ships, right? And they are very, very big. And they were scanning the crane on day 1. And then on day 2, to finish scanning, they went on site and found the crane to have moved, right? So Mark knows a technique to actually put the two together so that they don't have to retake the entire object, right? Okay, so there's one more, RM Bridge. Is that software from Bentley? If it is, then we can. Yeah, but generally, look, context capture produces common formats. And in fact, if you look at the brochure, right, which I can also send to you through Indra, we produce a lot of formats actually, which are very, very common, right? So I believe it should be able to be ingested. Yeah. Okay. Oh yes, then absolutely. I'm sorry, I'm very focused with my reality modeling because there are 300 plus softwares in Bentley. I do apologize. Yeah.
Okay, that's very interesting, Mr. Joseph. Oh, by the way, I want to ask you because actually I'm geodetic engineering. I'm in remote sensing.
Yes.
Yes, and I have a research about oil palm. Yeah, is it? I have a research about oil palm that I have to get the model from oil palm phenology. From such as just from one tree, is it the edge, oil palm edge, maybe 10 or maybe 5 or else? So is it possible to get the data or maybe the best model from Bentley for identified the phenology or the oil palm edge?
Okay, so so palm trees have a lifespan, I don't know, maybe like
25 years.
25 years. Yes. And they start from very small. Huh? So, and I spent 7 days in an oil palm plantation for your information to understand palm plantations. Huh?
Yes.
And phenotype is the outward display, the outward the final, what the plant is at the end of the day, right? And so on and so forth. Now, palm trees are planted. I mean, they are planted maybe 9x3 or apart, right? With some distance apart. And when you want to fly a drone, you would fly it above the crown, right? One of the things about the palm crown is that the palm leaves are very, very slim, right? And also they also move with the wind, right? So the size of the palm crown, you can generally you can measure, right? I think you can measure. You may not apply photogrammetry upon the image, honestly speaking, right? You may want to apply some other classification of the image, right? And you might use things like open source for leaf classification, right? Some of the leaves may be in different states of health, right? Different colors. So you might also mount a near-infrared camera together with your RGB onto your drone. Now, I'm talking outside of what context capture. Well, okay, yes, we can do some things within context capture, but some of the techniques will be outside of context capture, right? So, for example, NDVI calculation. Sorry, I'm going into agriculture. I should not be talking about agriculture, but so you can, right, fly a drone, capture the image. You can do classification. With context capture, you can actually make an auto photo from which you can do classification. That will give you an accuracy. Count the number of palm trees, for example, right? You can definitely calculate the height based on the digital surface model, and then you take away, the surface, and then you take away and remaining the terrain model. You can do that as well. But what kind of phenotype you are trying to capture? The images that you capture are not going to give you. Well, unless you inspect them, you eyeball them with your own eyes, right? Then you can make decisions, right? And I think the drone can really help you there, right? As far as making mesh models, well, if you can make a mesh model, then with the problems you face, right, with the palm leaves being so thin, the trunk, you can probably do a good job if you fly below the canopy. But flying a drone within a palm plantation under the canopy is not advisable, right? So yeah, you can do that. And also, of course, well, I think once you fly a drone within the palm plantation, it's different from flying above the crowns, and the limitation that palm plantations can be 500,000 hectares, and so on and so forth. The large one in Indonesia are 10 times bigger than Singapore.
Yes.
So I've met all of them, all the names. So I understand a little bit. So, but many of them use it for example, other things, where the small areas that they are planting, they want to monitor whether the young palms are growing well, right? They want to basically resupply, they call it. And drones are very good for that, I would say.
Yes, thank you, Mr. Joseph. That's I really need the informations about the oil palm because it's difficult to identify the age, the age of oil palm for general. Thank you so much. Maybe others mungkin dari Bapak Ibu yang lainnya apabila ada yang ingin didiskusikan bisa langsung we can direct here ya, sir. Bisa langsung tinggal raise hand, tinggal langsung mendiskusikan sesuatu mengenai konteks capture ini. Silakan. Ada yang akan didiskusikan dengan Bapak with Mr. Joseph? Maybe mungkin ada beberapa hal dari suatu pekerjaan atau project yang bisa didiskusikan bagaimana menggunakan konteks capture dan lain sebagainya. Mungkin Pak Indra, silakan Pak untuk disambung.
Katanya masih ada pertanyaan Bu ya di
Slido.
Coba kita lihat.
Okay, maybe you can continue to Slido link. We have from Bahri, my name is Bahri, 3D modeling from PT Sawari Gading Multi-Kreasi, survey mapping and IT solution, 3D modeling, very good for alternative solution to information needs.
Thank you very much.
Then we have Wildan in our photogrammetry research of counting. Maybe Wildan already.
Weather is one potential issue that can reduce the precision of calculation. I don't know what this means. How does weather affect the precision? Actually, I'm not very sure.
Maybe William already answer. Yeah, already answer.
Okay.
Maybe we can continue to next. From Unitarati, maybe she is student. I want to ask about Bentley software. Is there any student trial for 1 week or something like that?
Yes. So we will be engaging with my Bentley Institute member of Bentley to get that license to you through the university. Yeah.
Yeah, I think Kulsu already explained about this. Yeah.
Yes. No problem.
Yeah.
Okay, maybe next. In
Yes.
planning the construction port, can we collaborate marine harmony data with construction calculation in Bentley software?
I'm sorry, but can somebody explain what is marine harmony data?
Marine harmony. Pak Indra, apa ya marine harmony? Saya juga baru dengar kata marine harmony.
I don't know exactly harmony data, I think, or maybe the bathymetric data.
Bathymetric data.
Bathymetric.
Maybe, I don't know. Maybe.
Well, if it's bathymetric, I mean, definitely can. I mean, we're talking about, anyway, these are ocean surface or the depth, right? The ocean floor, which is actually just another surface model, right? So definitely it can be displayed together. It's not a problem.
Okay. Maybe last, I want to ask about the processing data, the corridor processing data. The result always apa ya pelangkung?
Curve.
The result always curve. Is there a special setting for corridor data?
Okay, so this was answered by Mark just now because of the camera settings and the collection method, I believe. Yeah.
Okay, sure. Maybe that's all.
Is that all?
Yeah, that's all, sir. There's no question again.
No worries.
Question already answered.
Yes. So thank you very much, everybody, for being so active and asking good questions. I hope we have answered, many of the questions. Do look through some of our, websites and so on. In fact, we do. I also wanted to send you another YouTube link here, just to tell you about the other technology that we have, which is Open Cities. So I would say we could engage in the near future, and please contact Pak Indra, Ibu Rika for any direct questions, or if you want to actually acquire the software as well. Okay.
Okay, thank you, Mr. Joseph. That's a very interesting. Maybe our student wants get the training about the software. Yeah, because maybe for their final projects or maybe for their research. And of course, in ICNAS, we have a lecturer in this research, such as me. So I think it's very interesting, and that's a context capture can explore to others. Besides geospatial, maybe we can use it in civil engineering or maybe in urban and else. Okay, silakan mungkin ada kata penutup dari Pak Indra. Silakan Bapak.
Okay, baik. Maybe before we close this webinar, maybe I would like to discuss with Mr. Joseph. I want to ask about is there any Bentley product training partner for the context capture in Indonesia?
Training partner, is it?
Yes, training partner.
Can you let me check this? I need to check. And if you are keen, let's take this offline. I think it should be a possibility.
Okay, yeah. Because as we already collaborate with Plaxis before, so and then right now ITNS already National Geotechnics Center already as a Bentley training partner for the Plaxis, just only for the Plaxis, and maybe in the future, if you don't mind, maybe we can also discuss with Mr. Kutur. So our lecturer in ITNS in geodetic engineering, maybe you can make a training for them, and then training for train, yeah, TOT, and then we can also make a training in bahasa, yeah, because because Indonesia many construction also need this. So I think if we can give a training in bahasa, it's much better.
Yes, I agree. And in fact, I think, yes, I hope you become a training partner, and I will definitely support it. I mean, thank you for the offer as well. I think, you know, you're very valuable as an academic body because, you know, then, you know, hopefully we can spread this capability, because Indonesia is very, very large. And there are many infrastructure projects, upgrade, improvements, you know, that need to be done. And then I think, and this is a digital journey, right? I think your president made a remark a couple of years ago to say, let's put Indonesia on a digital journey to enhance and transform Indonesia to become digital and therefore much better. So this is just a small part that you can play, and I hope Bentley can contribute to, right? And definitely I will support you, and definitely let's do it together in this year, right?
Okay.
Yeah. Thank you very much.
Yeah, welcome. Bu Ika, mau kasih pengumuman terkait dengan sertifikat dulu, Bu?
Ya, baiklah. Terima kasih. Baik, untuk para hadirin sekalian, untuk sertifikat akan kami kirimkan melalui email blast. Jadi, dimohon untuk mengisi absensi pada link yang sudah tertera di chatroom, nama lengkap dan juga alamat emailnya. Akan kami kirimkan nanti sore. Terima kasih. Terima kasih. Mungkin ditutup saja, Pak Indra.
Oke, baik. Okay, Mr. Joseph, on behalf of ITNS, I would like to thank you for this event, for this webinar. Maybe we will wait for the next series for the webinar about the reality modeling.
Yes.
Okay.
So,
dan juga kami ucapkan terima kasih kepada para peserta yang sudah hadir dari awal hingga akhir. Semoga apa yang tadi disampaikan oleh Mark dan juga Mr. Yosef mendapatkan wawasan, dan juga tadi memang saat ini di dunia konstruksi di Indonesia sedang sangat berkembang, dan tentunya dengan teknologi reality modeling ini akan sangat membantu seperti itu. Mungkin itu saja, Bu Rika. Sekali lagi terima kasih juga kepada panitia Bu Rika yang sudah repot dari sejak kapan, Bu, ya, untuk membantu terlaksananya event webinar ini. Dan juga insya Allah dalam waktu depannya kita akan melakukan lagi beberapa webinar series yang mungkin akan sangat terkait dengan Bentley gitu ya, dari software Plaxis, StartPro, dan mungkin juga ada software yang lain, Open Door dan lain-lain. Insya Allah nanti kami akan undang kembali Bapak-Bapak semua dan juga mungkin mahasiswa yang hadir di hari ini. Mungkin itu saja, terima kasih Bu Rika.
Baik, terima kasih Pak Indra. Okay, thank you Mr. Joseph for coming today. Silahkan untuk Bapak Ibu, maybe we can check a picture, screenshot.
Okay.
Yeah. Silakan untuk Bapak Ibu dan para hadirin sekalian untuk di-on-kan kameranya, kita akan berfoto bersama. Mohon dibantu untuk men-screenshot ke Anggita dan Firman.
Ya, Bu.
Ready?
Slide 1.
Baiklah, kita mulai. Oke. 1, 2, 3. Oke, slide berikutnya.
Thank you.
1, 2, 3. Oke, we have 4 slide here. Slide berikutnya 1, 2, 3. Oke, terakhir 1, 2, 3. Oke, terima kasih. Terima kasih atas kehadirannya. Mohon maaf apabila ada kekurangan. Kita bertemu lagi di webinar series reality modeling yang lainnya. Ditunggu saja informasinya. Bisa dilihat di Instagram ITENAS, @ITENAS Official atau @FTSP, Fakultas Teknik Sipil dan Perencanaan. Once again, thank you, Mr. Joseph. Maybe we can collaborate in another time, and maybe when COVID is over, maybe you can come to Bandung to ICINAS.
Oh yes, I went to Jakarta many times before COVID, and even in January last year, I was in Jakarta as well. So I really like the place. I think Indonesia is a wonderful place. So yes, I want to go one more time, many more times.
Sure.
Yeah.
You have to come to Bandung.
Yeah, I will go to Bandung for sure. And I will talk to you separately on the palm thing, the palm tree identification, because I just thought of some new ideas as we talked. Yeah, so we can talk about it. Yeah.
Yes, yes, sir. Thank you so much.
Thank you.
Maybe we can discuss it later. I mean, I will send you an email and maybe we will discuss it. Thank you so much.
All right. No worries.
Terima kasih sekali lagi. Saya ucapkan, saya tutup saja. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Bye bye.
Terima kasih Pak Gatot. Pak Gatot, terima kasih.
Okay, thank you very much, everyone. Thank you very much.
Thank you, Mr. Yosef.
Thank you, Mr.
Thank you. Bye bye. Thank you so much.
Thank you.
Thank you very much.